Okay, gentlemen, today we're going to look at the start of our linear functions. So first we look at slope, which is something you probably have seen before, right? The slope is the amount of vertical change in a ratio to the amount of horizontal change between any 2 points in a line. Okay, and we see our formula written right there, right? Change in y over change in x looks just like our distance formula. Right? Change in y over change in x. Our distance formula had x2 minus x1 and y2 minus y1. This has the same exact thing. And this is our slope. Now, if I have a fraction and an equal sign, I can always cross multiply those to the fraction on the other side. So if I take this and I cross multiply, the m is really over 1. I can get y2 minus y1 is equal to m times x2 minus x1. And this is the point slope equation of a line, with x1, y1 being the point, and then x2, y2 being our general form. And we could see right there, those two equations exactly match. Our point slope form of a line, which is really just the cross multiplication of our definition of slope. And this is where the line passes through the point x1, y1, and the slope is always m. Okay? Now, if we were to take that exact equation we just learned, y minus y1 equals m times x minus x1, and we say, let's say x1 is 0. So this is a specific case of it where the x value of my point is 0. Then our point would be 0, comma y1. And then what would we get? Well, we'd plug it in. Y minus y1 is equal to m times x minus 0. And then obviously the 0 drops out. We don't need that. And we just have y minus y1 equals m times x. If we add y to both sides, or y1 rather, to both sides, we get y is equal to mx plus y1. And this is the slope-intercept equation of a line, with y1 being b, right? You've probably seen it as mx plus b. Well, this is the exact same thing where b is y1. And we can see that written right here. They match. Right, so although you probably, not definitely, would probably know mx plus b is the equation of a line, and you've never seen the point slope form, really that's what we start with. The point slope form is like the initial form of a line, and the slope intercept, mx plus b, comes from that. The mx plus b one is nice because we have an intercept and a slope. Those are two important values. The point slope is equally as important because we have any point. Doesn't have to be the y-intercept and the slope, so that is nice. All right, so let's look at some examples here. So we write the equation. So write the equation of a line that passes through this given point, negative 3, 4, and the slope. So you can see right away, I have a point, and I have the slope. Oh, sorry, y-intercept. There we go. Y-intercept is 0, comma b, which we know, and my slope is m. So now we have a point in this one, negative 3, negative 4. And then we have our slope, 2. So I could do y equals mx plus b, but I don't have an intercept, right? That point is not 0, comma, negative 4. It's negative 3, negative 4. So it would be easier for me to use my point slope form. Y minus y1 is m times x minus x1. I have my point, I have my slope. So here's my equation with the missing pieces. I plug in my y value, negative 4. I plug in my x value, negative 3, and there's my slope, 2. Just like with the equation of circles, we kind of play with the minus negatives, right? We make that look a little bit neater, and we have y plus 4 is equal to 2 times x plus 3. Now, we can stop right there because that is the equation of a line. That is the point slope equation of a line that goes through the point, negative 3, negative 4, and has a slope of 2. Just like our equation of a circle, you plug in your point, and then for us, you plug in the slope here, and you're done. That's it. But the next one, same thing. We have a point, 5, comma 12, and a slope, negative 1/2. Same exact steps. I don't have a y-intercept. It's not 0, comma something. So why don't I use my point slope? I have a point, and I have the slope. We see our equation right here. We leave our gaps for what we're missing. I have to plug in my point, which is, well, my slope, -1/2, and my point, which is 12 and 5. Both of those are positive, but I don't need the double parentheses, and I get y minus 12 is equal to -1/2 x minus 5. Just like the equation of a circle, where the signs, because the formula is y2 minus y1 and x2 minus x1 for distance, and for equation of a circle, where it's x minus h, very, very similar, right? Where the form of it, the standard form of it, has a minus sign in it. Now, technically, as like a side note, you could take either of these. We'll look at the first one because there's a little bit more room there. And you could rewrite this equation of a line, y plus 4 is equal to 2 times x plus 3. And you could rewrite that equation of a line in our slope-intercept form, mx plus b, if you wanted. How would we do that? Well, just as we did up here, we would do the same. So here's my equation. Now, if I wanted to make this into my mx plus b form, I need y equals. So we're going to solve for y. First, distribute my 2 into the x plus 3, so I get 2x plus 6, and then very simply subtract 4 from both sides, and I get y equals 2x plus 2. And there is the mx plus b equation of the same line, the slope-intercept of the same line. These two lines are exactly the same. One's written in point slope, and one's written in slope-intercept. If we take a quick look at Desmos, here was the first line we had, y plus 4 equals 2 times x plus 3. And if I graph this line, look at that, it's exactly the same. They are directly on top of each other. So they are the exact same line. They are exactly the same. One is written from regards to a point and the y-intercept, and the other one is written as regards to any point and the slope. Okay, and now we look over here, write the equation of a line. So now we're up to the next one, write the equation of a line that passes through the point 0, -4. So let's say we were to say, well, there's our point and there's our slope, -3. If we were to try to write it in this form, we could. It would look a little weird, but we could, because we leave our blanks. Our y value is -4. Our x value is 0, and our slope is -3. Now, we let that drop down, and that's our equation. It looks a little bit weird, right? We don't really like to have -0. You could just drop that and have y plus 4 is equal to -3 times x, but this is a little clunky, a little odd looking. So from the start, we could have said, well, here's a point, and it's 0, -4. That point is an intercept, 0, -4. It's my y-intercept. So why don't I just use mx plus b, or mx plus y1 as we called it earlier? So I leave my blanks. My -3 is my slope. My -4 is my y value for my y-intercept. And there's my equation. Those two equations are the same. Did I graph those? I did. Those two equations are the same. Here's what we had. Obviously written pretty weird, and here's the one we're a little bit more familiar with, but again, exact same line. Exactly the same line. This one is written from the point of view of a point and the slope, and this is written from the point of view of the y-intercept and the slope. We happen to be given the point as the y-intercept. Okay, good. Next we have our last one, our equation of a line that passes through. Now we have 2 points, so we're not given the slope here, but we need the slope. So we have to solve for it. Slope is, m is change in y over change in x. We plug in our values, right? Again, as long as we're consistent with the order, it doesn't matter which one we pick is like x1 and which one we pick is like x2, but whatever you pick is x1 or x2, they have to be paired up together, right? You cannot jump back and forth between points. So we have, let's say, start with the red one, 4 minus 1, which is my y values, over 3 minus 1, those are my x values, and I started with red, and then I subtracted blue from red, and that obviously equals 3 over 2. All right, so now that I found my slope, I can use that to write the equation of a line. Now we need a point, right? We're going to use point slope. We can choose either point. It does not matter which point we do. So let's start with one of them. There's our equation for point slope, because we have 2 points here. None of those are intercepts. They're both points. We leave our blanks. I'm just going to fill in the easier one, the simpler one. Let's use 1, 1. Less room for error. So there's my 3 over 2 slope. Here's my 1, my x value. Here's my 1, my y value. And that's the equation of my line. Very simple. I have a point, I have a slope. That's the equation of a line. Or, what happens if I chose the other points? Well, here's my blanks. I fill it in. Here's my slope. Here's my x value. Here's my y value. There is the same line. 2 equations that are the same line. And we see here is the first one. Y minus y1 is 3 over 2 times x minus 1. Or y minus 4, 3 over 2, x minus 3. Again, they are exactly the same line. Exactly the same line. These 2 lines are the same. Okay, so gentlemen, I hope that helped clear up or introduce some topics with slope, point slope, and slope-intercept. And we're going to be doing a lot with point slope because very often we're not given the y-intercept. We could transform these into that, but that's doing a little bit more work than we had to. These took no steps at all. Once we found the slope, we just plugged it in and we were done. Okay, so you guys have some practice problems to do. Good luck with that.